So good day everyone. We will be discussing today the two types of algorithm, which is the binary search and the insertion sort. So let's start with binary search. So let's start with a searching algorithm. So binary search is an efficient searching algorithm used to find an element in a sorted list. Instead of checking every element one by one, it divides the list into halves until it finds its target. Binary search works only on sorted arrays, unlike linear search that works on both unsorted and sorted list of arrays. So let's start with this example. Suppose we have this sorted array 2, 4, 6, 8, 10, 12, and 14. Our target number to be found is target number 10. To do that, we have to take the left half of the array and the right half of the array, which is 0 and 6. That is our indexes. To get the middle value, we had to add 0 to 6, then divided it into 2. The middle value is 3. Now, the number inside the index 3 is 8. Since 10 is greater than to 8, we move to the right half. We disregard this half because we cannot find the value 10 there because 8 is less than to 10. Now, the left index becomes 4. We have to get the middle value of 4 and 6. To do that, we have to add 4 and 6, which is 10, divided by 2, which is 5. Now, the middle value is now 12. Since 10 is less than to 12, we move or we search to the left half, which is here. We move here. We disregard this because it's less than to 10. We move this because 10 is greater than to this number. Left and both index point to index number 4. The value in the index number 4 is number 10. That matches our target number. That's how you do binary search. The time complexity of binary search depends on how quickly the target value is found. In the best case, the target is located immediately in the middle of the list, giving the time complexity of O of 1. In the both average and worst case, the algorithm repeatedly half the search space, resulting in efficient time complexity of O of logarithm of n. In the space complexity is O of 1 because it only uses a few variables for indexing and does not require extra memory. Overall, binary search is fast and efficient since it narrows down the possible location of the target at each step.
On the other hand, in sorting algorithm, particularly the insertion sort, it is a simple sorting algorithm that builds the final sorted list one at a time. It works similarly to how you sorted cards in your hand. You pick a card and insert it in the correct position relative to the already sorted cards.
So our first key is 10. We compare 10 with 26. Since 10 is smaller, we move 26 to the right and place 10 in front. The array becomes 10, 26, 5, 6, 1, and 12. So the next key is 5. We compare 5 with 26. Shift 26. Then we compare 5 with 10. Shift 10. Now we insert 5 at the beginning. Now we have arrays 5, 10, 26, 6, 1, and 12. Our third key is 6. We compare 6 with 26 and 10. Shift both. When we reach 5, we stop because 5 is smaller. We insert 6 after 5. Array becomes 5, 6, 10, 26, 1, and 12. The next key is 1. We compare 1 with every number on the left and shift all of them. Since 1 is the smallest, we place it at the beginning. Array will be 1, 5, 6, 10, 26, and 12. Our last key is 12. We compare 12 with 26, Shift 26, we stop when we reach 10 because 10 is smaller. Now we insert 12 after 10. Final sorted array will be 1, 5, 6, 10, 12, and 26. And that is how insertion sort works.
The time complexity of insertion sort varies depending on how ordered the input list is. In the best case, when the array is already sorted, the algorithm only needs to compare each element once, resulting in a linear time complexity of O of n. However, in the average case, elements typically need to be shifted several times, which leads to a time complexity of O of n squared. The worst case also occurs when the list is in reverse order, requiring every element to be compared and shifted across the entire sorted portion, giving a complexity of O of n squared. Despite the higher time cost, insertion sort is efficient for small datasets and uses very little memory. Its space complexity is O of 1 because it performs sorting in place, requiring no additional storage aside from the temporary variables.
So in conclusion, in this video, we explored two classic algorithms: binary search, which is fast and efficient for searching sorted data, and insertion sort, a basic yet intuitive sorting method. Thank you for watching, and I hope this helps you understand on how this algorithm works.